Before we start this video, a large thank you to Alexander, Joel, and Tabby for their support on Patreon. I hope you guys enjoy the video. And, as always, a massive thank you to Halo Burner and Ryan Bellin for their immense support of the channel this month on Patreon. It is greatly appreciated, gentlemen, and I hope you enjoy the video. Hello guys, today we're going to make some functionality to separate our collisions from our renderers. So let's go ahead and create a new script. And I'm going to call this World Location Renderer Manager. So this is going to be placed in every scene that you have, and this is going to keep track of the renderers and root game objects in every scene that you have that is loaded in. So let's begin by dropping in our namespace, deleting the start and update functionality -SG. And I'm going to come up here and say right under using Unity Engine, I'm going to say using Unity Editor. This will come into play later. So the first thing I want to do is come down here and make a header, and we're going to make this for the scene ID that this is in, and this will be a variable of an int. And we don't need to see this either, so we can also say hide an inspector. This is basically just going to be used to grab the scene that this game object is in by getting its build index. So then right below that, we're going to make a header for root game objects, and this is going to be a list of every root game object in this scene. So think of all the root objects you have in your scene. Maybe like for structure, you have floors, ceiling, walls, etc. This will be all of those root objects. So I'm going to say using system.collections.generic, so I can actually use this list variable. And then we're going to make this a list of game objects. Alright, cool. So right below that also, we're going to need to keep track of the renders. And again, this will be all the mesh renders in the scene, not in other scenes. It will be contained only in the scene that this World Location Renderer Manager exists in. So basically, you're going to put one of these in all the scenes that you want to grab the renders and root game objects from. Little note, if you're using netcode for game objects, don't put this in a scene where you have in-placed network objects, unless you're not going to disable the root objects, because you can't start with an in-scene placed network object disabled. It has to always be enabled when the scene is loaded. So let's make a coroutine also for toggle all mesh renders coroutine, and I'll speak a little bit more on that later. We can start by on the awake method saying render scene ID is equal to gameobject.scene.buildIndex, and just like that, we just get the build index using the game object. Very easy. So let's go to the World Location Manager now, and what we're going to do is make a header first for this locations, for players and locations, so we can separate it. I'm just going to call it locations. Then I'm going to make a header for the renderers, and we want to keep track of all the active World Location Renderer Managers, because again, remember, these are going to cycle in and out as your scenes load and unload, so we want to keep a list of all the active ones. So I'm going to make a public list World Location Renderer Manager, location renderers equals new list, World Location Renderer Manager. And then I'm going to make a comment down here for location rendering. And I'm going to make a public void add location renderer to list. And we're going to pass the World Location Renderer Manager, and I'll call this Location Renderer Manager. Next, we do a for loop here, and we're going to iterate through all of our location renderers, because remember, these are constantly being added and removed as scenes are loading and unloading. And we're going to check for any null entries. So we're going to say if location renderers I is equal to null, then we're going to simply remove @I. So we're going to say location renders dot remove @I. And this will just clean up the list every single time you go to add a new one, basically. And then after that for loop, we can just simply check and see if the list already contains the location render manager you are trying to add. And if it does not, we can add it to that list by saying location renders dot add location render manager. All right, so let's call this over here now, and we're going to call it on awake. So we can say world location manager dot instance, and then we can just call the function add to list. Now, if you're worried about this being called on awake, you might say, well, what if the singleton hasn't gotten accepted yet? You could put it on start, but you don't need to do that, because the singleton will always be fetched first if you're only using this in additive scenes, because additive scenes are added on after the world scene is already loaded, and the world scene loads, and then the location manager will basically set up the singleton that way. So on start, then we can also make two pseudo comments here. We're going to do this in a moment. Check if a loading screen is active, and if it is, turn all your root game objects on instantly. If not, you might want to enable them one by one over a few frames, so you can prevent the likelihood of stutter, but we'll get to that in a moment. Let's actually make the functionality first for finding the game objects and mesh renders, and then enabling them. So we'll start with finding the game objects. We'll call this find all root objects. This one's easy. We say root game objects is equal to a new list of game objects, and then we make an array of game objects. We call it root objects in scene, and then we're going to say gameobject.scene.get root game objects, and that's it. So then we can iterate through this array. We're going to say a for loop, and we're going to go through this array of root objects in the scene, and we're going to say if root objects in scene I is equal to this game object specifically, continue. We don't want to add that to our list. We want to exclude this because this is going to be a separate game object that will control all this stuff. We want to keep it active. Then we're going to say if root game objects contains the object you're trying to add in this array already. If it's already there in the list, don't add it, continue. Finally, if it's not, we're going to say root game objects.add root objects in scene I, and then we'll say root objects in scene I set active false. We'll just disable them all after we find them by default. Okay, now, why we wanted to use Unity Editor. I will speak more on this later, but basically, I'm going to put an if statement here, but it's not a normal if statement. We're going to say $if Unity_editor. We're going to call editor utility. So editor utility.setDirty, we can pass this. And then we put the $, and if. Now, what does this mean? Because maybe some of you haven't seen this before. Well, if a scene change is made by functionality from a script, for example, if we call this from an editor tool, the scene won't actually register as having a change. So if you save it, it won't save your changes. But if you call setDirty, it forces the scene to register a change. So any change you've made with a script without actually manually doing it in the scene, you can now save it. This if Unity editor thing makes it so it's only called if you're actually in the editor and not in a build of a game. You actually have to put this here, or else if you do a build of the game, when you get to the editor utility part here, you will get an error in your build. So anytime you call this functionality, you have to do a check to make sure you're in the editor. And when you're in a build of the game knows this is not the editor, so we'll skip this code entirely. So this, again, basically makes it so any changes you make with inspector tools that we call this function from, without making it actually in the scene yourself manually, you can save them. Now, next, let's make a function for finding all the mesh renderers. And what we're going to do is make an array of mesh renderers. And this one's a bit more, I'm not going to say difficult, but it's not as easy as getting all root game objects from a function. That was certainly pretty straightforward. This one, we need to do a find objects by type, and we need to do mesh renderers. Now, you're never going to run these functions in-game, don't worry. You only run them in the inspector when you're building your world, because obviously find objects by type is an expensive call. We're going to say find objects inactive, include, we want to include those, and find objects sort mode is equal to none. Now we need to check to make sure that we're only getting renderers from our scene. Well, how do we do that? Well, we're going to say first, mesh renderers is equal to a new list, mesh renderer. And if that name is confusing for you, by the way, you can rename this to mesh renderers in scene. And if you want to, you can rename root game objects to root game objects in scene. But it doesn't matter as long as you know what it is. It might be confusing to read at first glance. It looks all very similar. So we're going to iterate through all mesh renderers. This is going to get all of them in every scene. And we want to check to make sure that the mesh renderer we need specifically is only in our scene. We do that by saying if all mesh renderers I.gameobject.scene does not equal this game object's scene. So if it's not equal to the scene that this manager is in, we want to continue. And then we want to make sure that it's not already in the list. So we're going to say if the mesh renderers in scene does not contain this specific mesh renderer, then yes, add it to our list of mesh renderers in scene. All right, that's basically it. Now we're going to do one more for loop and just disable them all by default. So we'll say mesh renderers in scene dot count, and if somehow it's null, it shouldn't be, but we'll check anyway. Continue. Then otherwise we're going to set as active is equal to false by saying mesh renderers I dot enabled is equal to false. Okay, cool. Now we can come down here and do a public void toggle all mesh renderers. And then we can do a bool for status. And what we're going to do is simply copy this for loop for all of our mesh renderers in the scene. And we change the enabled from false to status. And then we can do the same thing here for the root game objects. And we can also put this check here for the editor. If we're the editor, setDirty. So if we're doing this from our tool, which we're going to build later, we can save it. Okay, now let's do one for toggle all root game objects. So instead of looking through the mesh renderers list, we're going to look through the root game objects. So change this to root game objects. Again, if it's null, simply continue. And then instead of saying enabled, we're going to say set active is equal to status. Okay, so there's only two things left to do. Two functions. And these are functions that are optional. I'll explain why. I'll get into the pros and the cons. So we're going to make a coroutine here for enable game objects over time. And after, we're going to make one for enabling the mesh renders over time. So the game objects over time you probably want to use. And this one's pretty straightforward. We're going to go through the for loop here, and we're going to set the game objects active to true, but then we're going to wait one frame between each. So this is a coroutine, obviously. So we're going to say yield return new wait render frame. Now, generally speaking, you probably don't have more than like a dozen to 24 root game objects. So within 24 frames, or less than a second most of the time, all these are going to come on, and this is going to lessen the load on your device when enabling them, because they're all not enabling at once. We're going to say using system.collection, so we can actually use this coroutine. So we can say enable one root game object per frame, and this is generally a good idea. So if there's a loading screen, you don't need this. You can just say toggle all game objects true and do that instantly, because there really doesn't matter if there's a small stutter if there's a loading screen up, you're not seeing it. But if you're actually in the world, so what you want to do is use the coroutine to toggle them all over time. Now, I'm not covering loading screens because that's outside the scope of this mini-series, but we're just going to put the function here for enable them over time. We'll just assume that we're always in the world. Now, keep in mind, if for some reason you have thousands of root game objects, you need to make a calculation that will enable them all in X time. You can't just do it as one per frame because that will get kind of costly, but I can see a world where most people are going to have thousands of root game objects. I have a pretty big world in my project, and at most in a scene, I think I have like maybe a couple dozen. So now we're going to make one for toggle all mesh renders over time. Now, we have a coroutine variable here because you're not going to call this one on awake. I mean, you can if you want to, but you're probably going to call this one when you're deciding which renders you need as you move through the world in a multiplayer game. Here's why this one's a bit more weird. Toggling mesh renders all at once isn't so bad. Toggling them over time, you're going to have to make a calculation to determine how many you want to enable per frame or per second or whatever time you want to use as measurement, because oftentimes you're going to have thousands of these, like hundreds or thousands at least in a bigger scene. So basically you don't want to enable one per frame or you're going to see them pop in. So what I'm going to do is make a placeholder function here. I'm going to say yield return wait for end of frame, and then I'm going to do a for loop, and we're going to go through them, and then I'll just enable them all instantly. I don't actually use this in my project, and I don't find it has any negative effect on my performance when loading all my renders in at once. I just toggle them on or off, but you could make a calculation and then basically wait a set amount of time here and then go to the next one. But like I said, you're probably going to have lots of these because renderers are on every object you have in your scene. Usually root game objects will just house, hundreds, if not a couple hundred or a few hundred, even thousands of other game objects. Renderers are on each of those individual objects. But I'll show you where you can use it still if you want to. And now we're going to go to the World Scene Manager. What we want to do here is actually make some logic now. We have check for unrequired scenes. We want to make one for check for unrequired renderers. So again, if you're in the world with me and I'm in a different area than you, I only need to see my renderers in the scenes that are loaded. I don't need to see the scenes that you have loaded in your renderers. So if I'm the host though, I still need to keep those scenes loaded for their collisions. I just don't need to see their renders. So we're going to run this from the local player's point of view only. So basically, if there's multiple players in the game, it's not going to take into account player 2, 3, or 4. If you're not player 2, 3, or 4, it's only going to take into account your player. We need to see what scene renders you need loaded because this is only a visual thing. So let's go up top and make a header for scene renders. I'm going to make a private coroutine here for check for unrequired renderers. Okay, cool. So I'm going to just take this coroutine now, and we're going to make a function for it, and we're going to check if it's null. If it's not null, we're going to stop it and restart it. Because if this is called while it's already happening, for example, just stop the coroutine and restart it with the updated information. So if check for unrequired scenes coroutine does not equal null, or render, sorry, stop that coroutine. Then we're going to say check for unrequired renders coroutine equals start coroutine, and we're going to call this function we just made. So the first thing we need is a list of scenes relevant to the current area. And we're going to say this is equal to, and we need a world location. So let's make this require a world location. So we're going to say world location, location currently in, but then we're going to say, well, how do we get that? Well, we need to pass the world location of the local player. Well, how do we get the local player? Well, there's a bunch of ways to do that. In my game, I keep track of it when the game starts, so we can just make a super rudimentary way to do that real quick on our player manager. We can say public static player manager. We can call this local player. I keep track of mine on my player's camera or my player's input manager, depending on the project. And then on network spawn, which is called when this game object has been spawned, we can check for ownership. And for those of you who don't know what ownership means, if you're just new to using netcode or you're just doing it only for this series, it means basically if we're the owner of this specific game object. And if this is a player object, if we're the owner, it means this player is actually us. So this is what we want. So if this player is us, then we're going to set the local player variable up here to this. So put simply, when a bunch of players spawn in the scene, they're not going to fill that singleton unless the local player game object is us. So now we pass the player manager dot local player. There we go. And we're going to pass the location currently in. Okay, so now we're going to come over to scenes relevant to current area. We're going to say equals location currently in dot get all required scenes for this location. And then we're going to pass a list of int, and we're going to say scene build indexes is equal to a new list. And we're going to say list int. And now we can make a quick function to populate this list of build indexes. So we're going to say if scenes relevant to current area does not equal null. So if we actually have a list of scenes here, then we're going to do a for loop and we're going to iterate through those scenes. And then we're going to say scenes build indexes dot add. And then we're going to make a function really quick. So we want a way to get the build index from the scene name, because remember, we're getting the scene name as a string variable from this function up here. So we're going to say private int get build indexes from scene ID. And this is super simple, just a couple lines. We're going to make this require a string, call this a scene ID. And then we're going to say int build index is equal to, we're going to say scene utility dot get build index by scene path and pass the scene ID and then return our build index. Super simple. Then we say scene build indexes dot add get build indexes from scene ID, and then we're going to pass the scenes relevant to current area I. Okay, cool. Now right below that, we can do a for loop, and we're going to iterate through our world location manager dot instance dot location renderers dot count. Now what are we going to check in these renderers? So we're going to basically iterate through every active renderer manager for all the scenes. And then we're going to say if world location render managers I is equal null, simply continue, because as scenes are loaded and unloaded, it's possible to have a null entry in the list. Skip it. And then we're going to say if scene build indexes dot contains world location manager dot instance dot location renderers I dot scene ID. So basically, if the scene ID of this specific renderer is the same scene ID as a scene build index that we need, well, we know we need to keep the renderers on. So we can toggle them instantly. And here's where, as I said before, you can make the call to toggle them over time. So if there's a loading screen, you always toggle them instantly. Otherwise, optionally, you can toggle them over time if you want, or you can still toggle them instantly. So I'm just going to toggle them instantly. Otherwise, you want to disable them instantly, or again, over time if you'd prefer. So I will say disable instantly. All right, cool. What's next? Well, right below here, you're simply going to say yield return null. All right, let's save that. And now, where do we call this? Well, what you want to do is copy this function, and depending on your game, you might need to call it in a few other places, but on scene event, come down here to on scene load complete and call it right there. Check for unrequired renders. And now you are good to go. So we're not quite done yet. We have no way to automatically populate our world scene render managers with stuff from our scenes in the game. Obviously, you don't want to drag in all the stuff all the time, and every time we make scenes, if we forget to drag it in, that would break the whole set of logic. So what we're going to do in the next video is make some inspector tools to make it so that we can auto-populate all of these renderers and game object lists as we make changes in the scene. Thank you very much for watching. I hope you guys learned something. Hope you have a fantastic weekend. Thank you to my patrons for keeping my lights on, and thank you to the people who share my videos and series via word of mouth, and also take the time to leave a comment and like the video. I will see you guys next week.